Hello, this is James Weeden, computing ID JMW7DC for my Module 7 PWM project. So first, looking here, I have my pulse width modulation set up. So I basically just made two configurations to set the robot's clock source to the SMCLK clock so that it could have a 12 megahertz original frequency, and then I just had a divider to get to that, 24 megahertz original, and then a divider of 2 to get to 12 megahertz. I got the capture compare registers properly set here. And also I have this duty cycle to CCR value, so I can get that, whatever that percentage is, into an actual CCR value to pass in. So in my init here, I basically just set up the passed in period and duty cycles, pretty straightforward, and then just use these fancy generate PWM functions here to start the pulse width modulation. Here, all I do is pass in the duty cycles such that, you know, if I were to pass in a 50 as my duty, it would basically apply the voltage for 50% of the period, and 75 would be 75% period, and etc. Going here to my motor skeleton file, I essentially just initialize here with the 15,000 period, get my pin set up here. Yeah, basically this just, you know, follows all these rules here, just gets it all the pins set as outputs, so that we can start getting that direction and we can get the sleep mode. Originally it's sleeping. And then here I have these more or less straightforward functions as well, for forward, backward, left, and right. I guess the things to note here are that I basically leave sleep mode by setting the output to high for those pins, and then I set the output low actually to drive forward, which was a little confusing at first, to be honest. But doing that, it can drive forward. Output high will actually make it drive backwards. And then I set the duty using those two functions from the pulse width modulation. Same thing with backward, except I just reverse the direction. Motor left and motor right. The only thing I'm doing here is that one of them I'm setting high, one of them I'm setting low, so that, you know, one wheel is rotating clockwise, the other one is rotating counterclockwise, so that the robot can actually turn. Motor stop, of course, just direction doesn't really matter, but I just put it in the sleep mode and put the PWM to 0. Okay, and looking at our main function here, we essentially just drive forward, turn right, stop, drive forward, turn left, stop, drive forward, and drive backwards. It's pretty much just random movement just to show that each of these can work. The delays are so that, you know, I don't move forward and it rapidly switches to going to the right, because then we wouldn't really be able to see much. So the longer the delay is, the longer it'll move in that given direction. So going to the actual robot here, yeah, I just tripped. If I click this button here, it will go forward, turn around, go right, go left, turn around. It basically just goes in this continuous sequence of forward, I think right, left, backwards, and then it stops. But it is not a very intelligent robot right now, so it kind of just does its thing. But it clearly works. It can clearly turn. It can clearly go forward. Don't do that. Yep, it can clearly go backwards. So I'm gonna stop it before anything happens. Stop. There we go. But yeah, that is pretty much it. Thanks for watching.